Hello, I'm Professor Patrick Treacy, and a lot of people have been asking me recently what exactly are secretomes, because they know I'm going to be speaking about this in Asia. So the secretome is essentially a collection of biologically active substances released from cells into the surrounding environment. These things include growth factors, cytokines, chemokines, lipids, peptides, proteins, messenger molecules, and extracellular vesicles, including exosomes. And I suppose for many years, rightly or wrongly, we focused on the cell itself, particularly on stem cells. But increasingly, we understand that much of the therapeutic benefit may not come from the cell becoming new tissue, but rather from the signal that it releases. Right or wrong, there's where we're focused at the moment. So in other words, the cell acts almost like a biological pharmacy, sending instructions to nearby cells to repair, regenerate, reduce inflammation, improve vascularity, and restore hemostasis. So these are the things that I've always been interested in anyway, and this is what makes, for me, secretomes so interesting to a large extent. They represent a move, I suppose, from cell therapy towards cell-free regenerative signaling. Now, I know that recent dermatology reviews in some of the magazines describe the mesenchymal and stem cell-derived secretomes as containing growth factors, regularly RNAs. They can modulate inflammation, as we said, support repair, influence skin homeostasis, but also the stress that we have to look at clinical data standardization. These are the real things. Somebody else has asked me a question recently, are secretomes really new? And because I've been involved in science a long time, I suppose I'm in a position to answer that. They're certainly new in branding, but certainly not new in biology. The concept that cells communicate through soluble factors has been with us for many, many decades. And I suppose what's new is more scientists' ability to isolate, characterize, concentrate, and apply these signals more deliberately. In aesthetic medicine, we've already been working in this direction for many years. I started working with PRP in medicine back in 2003, so that's, 24 years ago now. Then low-level light, biomodulation, and other biological stimulatory methods. Secretomes, I suppose, are part of that evolutionary journey. So I certainly wouldn't call them a sudden revolution. I call them more a sophisticated language for something that has been moving forward for quite a long time, and we're using biological signals rather than mechanical correlation, if that sort of makes sense. When I was in Monaco, we were asked this question, and also in CME Rome, and we didn't really address it properly. Why are secretomes different than exosomes? Is this an important distinction or not? So we've got to consider that exosomes are only one component of the secretome. The secretome is the broader mixture of substances released by the cells. So they would include soluble growth factors, cytokines, proteins, peptides, lipids, and other extracellular vesicles. Exosomes are small extracellular vesicles within that larger secretome family. I suppose the mistake in the marketplace that people often use regarding exosomes and secretomes is that they use them interchangeably, as almost as if they were the same thing, and this is because of this sudden interest, particularly in their regrowth of hair tissue and skin tissue. So secretome, as I've said before, is more like a full orchestra. Exosomes are only one section of that orchestra, certainly not the whole symphony. And I was asked only a few days ago, why are secretomes gaining so much traction or interest now in regenerative medicine? I think the answer is because they potentially give us many of the signaling benefits of regenerative medicine without the complexity of transplanting live cells. In theory, they can help influence inflammation, angiogenesis, fibroblast activity, collagen remodeling, pigmentation pathways, wound repair, tissue quality. And these are all highly relevant to dermatology and aesthetic medicine. So people are looking and saying that aging skin is not just a volume problem. It's a problem of cellular communication, chronic inflammation, extracellular matrix degradation, impaired repair mechanisms, oxidative stress, reduced regenerative capacity. And we've seen this particularly well with using red light and stem cells together. So secretomes fit into this naturally into the future of a field. They move us beyond simply freezing or filling or resurfacing towards the biological behaviour of the cell itself. People always ask me as well, how can secretomes be used clinically? Well, I suppose logically the areas would be where I use them a lot is post-procedure recovery, skin quality, barrier repair, inflammatory modulation, scar improvement, hair restoration, wound healing, and possibly also photoaging. In clinical practice, as yet, I would say their safest role is that of an adjunct. For instance, we use them a lot after CO2 laser resurfacing, and some of our doctors also with erbium resurfacing, the nurses with microneedle radiofrequency and other procedures that we're already creating a controlled wound healing response. And I suppose in many ways the aim would not be to replace established methods, but to improve them, reduce inflammation and perhaps even enhance tissue remodeling. So that's as much as I'm going to do today. It's nice to chat to you from Dublin, and I'll update you over the next few days also on some of my upcoming lectures. Particularly, I think we need to deal more with secretomes and exosomes, because we didn't address it fully in CMA Rome. I know myself and Ernesto had a head-to-head regarding it, which was always lovely to have academic interests and challenges, but the people were trying to get in the door for the next lecture, and they sort of, to an extent, forced the session to close too early. But anyway, over and out from Dublin at the minute. Thank you.